Okay, with this lesson we're looking at tan graphs. So the basic tan graph here is shown in the yellow. So if you think about the unit circle at 0, when the angle is 0, tan is 0. But then when you go to pi on 2, remember that it's undefined. So that's why we're asymptoting. When the tan graph goes up, it never touches because it's undefined, so it asymptotes. So you can see that the cycle keeps repeating, but if you note, it only takes pi to complete a complete cycle. So that's pi in there. So the period of a tan graph is actually pi. So for a basic tan graph. So if you're going to find the period of the tan graph, so down here, you're going to do pi divided the number in front of the angle. So remember, for cosine and sine, it was 2 pi divided by n. Okay, so the first asymptote occurs at half the period. So you can see, because this one's pi on 2, and then you add a period to that and you get the next asymptote. So for a tan graph, the amplitude's undefined because you can see it asymptotes up. Alright, so if we have a look at these graphs here, it says sketch the graph of each of the following for x is an element. So that's just telling you the domain. So if you have a look, we only want to go from negative pi up to pi. So we're only showing that part of the graph. Okay, so we should go about and find first the period. So it will be pi divided by n, and in this case it was 2. So pi on 2 is the period, and the amplitude, as we said, it didn't really matter. That's not going to affect. So remember that the first asymptote is at half the period. So half of a half is a quarter. So you got pi on 4. So we've sketched in here pi on 4, and then we add another period, which would be then 3 pi on 4. Okay, and then you'd add another half a period, so we go up to here. Okay, now this is a positive tan graph, so we start there and we go up there and so on. Now because we've got to go negative, it will go back there, and we've got to keep going back. Alright, with this second example, it's got a negative, so it's reflected, so it means it's starting at a different. So if you go back to 0, we normally go up, well, it's going down, or it's reflecting. Now we could get the period of this graph. The period would be pi divided by 3. So that's the period. So the asymptotes are happening at half of that, which is pi on 6. So you can see I've put all the asymptotes, and you keep adding on a period. So here you've added on pi on 3 to get the next asymptote, and so on. And then they will, so because we wanted to, same domain as the question before, so we've put them all in there. Okay, so we're going to go back and look at some of these equations for solving for tan. So solve each of the equations for x. So what they've said here, we could have how many solutions? So if you think we're going backwards to negative pi, and we're also going forwards to pi. Okay, so if you look here, the period is 1. It is still pi. So first of all, when does pi equal negative 1? So if we look through, if we put the 45 finger down, we'd have the square root left over the right, so that'd be 1. So when it's 45, but we need tan to be negative, so remember, cast. So in the third, tan's negative in second and fourth quadrant. So if you see here, second and fourth. Okay, so it is when you've gone that distance into those quadrants. So we remember 45 is pi on 4. So it's when we've gone back here, pi on 4. So pi minus pi on 4 would be the 3 pi. And then also if in the fourth quadrant. Okay, now because we only want to go between pi and negative pi, if I go around here in the positive direction, that'll be out of my domain. But if I go backwards into the negative area, back that way, that will be okay. So I can say if I go backwards once, I'll get that backwards answer. Alright, now with the next example, so the period for this one is pi divided by 2, okay, and they want to know when it equals square root 3. So remember tan with exact values is the square root left over right, so I need the 3 fingers here, so that means I've put that one down, which is pi on 3. So tan equals square root 3 when it's pi on 3. Now remember we said just ignore that it's the 2 here, and we're just going to pretend when it's normal. So when is tan equal to square root 3? When we have pi on 3. So if you think of the unit circle, we've got pi on 3. Now tan is also positive over here, so it'd be pi plus pi on 3. So the two answers we'd have is pi on 3 and 4 pi on 3. Okay, now because we have to go the minus way too, so if we're going minus, it would be not quite at negative pi, it'd be just short of it. So that's where we've got the negative 2 pi, and we keep going around. If we kept going around, it would be just before we get to negative 2 pi, which is this final answer. Now because the question wasn't, it was 2x. So what you've got to do is you take your answers that we got up here, remember, we bring the 2 down, whatever number's here, and we times them by 2, because it's like you're moving that 2 over, and it's timesing here to divide on the other side. So then you get these answers. Now remember, these answers have to fit into the original domain, so they have to be in between those two values, which they are. Okay. Here they want me to sketch the graph of tan 2x. So I've found the period, which is a half, and I've worked out the asymptotes are at a quarter. So I've put all them in, and I've gone as far as I need to. Now we've moved it up one. So where we would normally start here, that's moved up. So our 0 line essentially is now on y equals 1, and that's where we started from, and the twist will happen and so on. So that one would actually, sorry, this one should actually go like that. Alright, now you can see you have a y-intercept and x-intercepts. So here we've found out, so tan, we're trying to find the intercept, so tan 2x plus 1 equals 0. We've let y equals 0 to get the x-intercepts. And so here we go about, and it ends up being like finding solutions. So you find it for normal here. So here's where the normal is, because it's 2, we times by 2. So we know this is the x-intercepts, that's when it crossed the x-axis, and you pop them in there.